Hello and welcome to EduSathi. We'll be moving to Module 2 on Algebra, and this lecture 1 we'll be talking about algebraic expressions and linear equations. Now you guys have already covered the Module 1, which was on arithmetic. The main difference between arithmetic and algebra can be seen as that of a variable, which is a letter that represents a quantity whose value is unknown. Usually we'll be using the variables x and y. However, you can choose any variable depending upon your convenience. So let's get started and understand what do we mean by algebraic expression. Now, to understand this, let's look at a thing that I've written. Now, if you look at it, this is an algebraic expression. It's a combination of numbers. I have a number in this. I have other numbers and one or more variables. So if you look at this equation, the variables that we have are x and y and can be written as a single term or a sum of such terms. So an algebraic expression would constitute of variable. Now if you look here, x and y are variables that we have in this equation. It consists of a constant. A term that has no variable associated with it is known as a constant term. So if you look here, 10 here is a constant term that we have. Its value does not vary depending upon x and y. The third thing that you need to understand is coefficient. A number that is multiplied by a variable is called as a coefficient of a term. So if you look here, this x cube is multiplied by 4. 4 is the coefficient of x cube. Here 11 is the coefficient of x square, y square. Minus 5 is the coefficient of y square. 7 is the coefficient of xy. So a number that is multiplied by a variable is known as the coefficient of that term. And power. Now, the power of the variable gives us a clearer picture of what type of an algebraic expression is it. So power is what a variable is raised to. How many times a variable is multiplied by itself to get us a desired expression. Now, algebraic expression can be classified as linear, quadratic or cubic and so on. Now, this classification is based upon the degree of the expression. Degree refers to the highest power of any variable. So, we have x and y as variable. If I look at the highest power of any variable, that will be termed as a degree of this equation. So, on the basis of degree, I can term the polynomial or an algebraic expression as a linear, as quadratic if the degree is 2 or cubic if the degree is 3. Another way of classifying the same would be on the basis of number of terms. So depending upon the number of terms in an algebraic expression, I can say whether it is a monomial, that means it has only one term. It's a binomial, that means it is consisting of 2 terms. Trinomial consisting of 3 terms and so on. So let's look at a question that we have. Which of the following is not a polynomial? So I have 5 options which are given to me. I have to find out which of the following is not a polynomial. So if I look at the options, I have a variable whose power is 2, perfectly alright. Again a variable multiplied with a coefficient, again a constant term. Perfectly alright, this is a polynomial that we have. But if I look at the second answer option, the variable is in a square root sign. A very, very important thing that I need to keep in mind whenever I am talking about algebraic expression is variable should have an integral power. The power of the variable can be 1, 2, 3, so on, but it cannot be 1 by 2, 3 by 4. I cannot have a fractional part associated with a variable. So this answer, option number B, would be my answer for an algebraic expression not being a polynomial. Now, what are the various operations that you have associated with algebraic expression? The first one being addition or subtraction. Now, whenever you have an algebraic expression, you can only add up or subtract the terms which are like. Like means in terms of power. The terms with the same power can be added or subtracted. So if I just look at an example which is there, this is an algebraic expression that we have. Now, if I look at the terms containing z square, 5z square minus z square, I can combine the coefficient of this term, I can add or subtract the coefficients, and I can write down an algebraic expression in the following way. I can do the thing by simply adding or subtracting the coefficient of the like terms. So similarly, if you look here, this is 3xy, this is xy, 2x and 3x. This can be combined with this. 3xy minus xy gives an answer to 2xy. 2x minus 3x gives rise to minus x. So I can combine the coefficients of the like terms. The second one that we'll talk about is multiplication. Now, in order to multiply two algebraic expressions, each term of the first expression is multiplied by each term of the second expression and the results are added. Let's look at the case. So you have this. First, x will be multiplied with all the terms of the second. So x will be multiplied with 3x, x will be multiplied with minus 7. Then 2 will be multiplied with 3x and 2 will be multiplied by minus 7. And then I will add or subtract the thing depending upon what are the coefficients. And again, add up or subtract the terms having similar powers of the variable. So I'll end up with an answer which is 3x square minus x minus 14. The third one being the division. Now, whenever I have a division thing as well, I can take out the factor common. So if you look at it, 7x square plus 14, from the numerator I can take 7x common, I'll be left with x plus 2. From the denominator I can take 2 common, I'll be left with x plus 2. Now this x plus 2 is a common factor that can be cancelled from the numerator as well as the denominator, leaving me with an answer 7x over 2. So this is how we deal with algebraic expression. Now what is our equation that we have? If we talk about a statement of equality between two algebraic expressions that is true only for certain values of variable involved is called as a equation. Now, the values for which the equation holds true are known as solution of the equation. So the values would be known as solution of the equation, and the statement of equality between two algebraic expressions is known as an equation, provided it holds true only for certain values of x. And these values of x are known as solutions of the equation. Let's look at an example. You have a linear equation in one variable. Why linear? Because the degree of the equation is 1. There's only x which is raised to power 1. And one variable because there's only one variable x that you have. So you have this equation. What you can do is you can solve as this equation. So once you solve out this equation, you will look at it. It'll have 3x is equal to minus 2 minus 5 and x is equal to minus 7 over 3. Now, if you look here, if you look at this equation that you have, or if you look at another equation that you have, it's again a linear equation which can be represented in two variables. The two variables that you have here are x and y, and the power of each of these variables is turning out to be 1. So it's a linear equation. Now, if you look at these two equations that you have in front of you, these two equations are valid for certain values of variables. They are not valid as such, they are valid for certain values of variables. So those certain values of variables would be known as solutions of this equation. Now if you look at the third one, it's a quadratic equation. Why quadratic? Because the degree of the equation is 2. So you have degree of the equation as 2 and it is only one variable. Y is the only variable that is there. So again, this equation, the left hand side will be equal to the right hand side only for certain values of y. It will not be equal to right hand side for all values of y. Those certain values will be known as solution of this equation. Now there are certain basic algebraic identities that I need to remember when I am doing question. Now what is an identity? Identity is an equality which holds true for all the possible values of the variable. Now, equation holds true for certain values which are known as solution, but an identity is an expression that holds true for all values of the variable. And there are certain basic identities that I need to remember. The first one being a plus b whole square would be equal to a square plus b square plus 2a. Similarly, if you have a minus b whole square, it will be opened up as a square plus b square minus 2ab. The third one is if you have a plus b into a minus b, it can be written as a square minus b square. Or if you have a square minus b square, it can be written as a plus b or a minus into a minus b. The next one being a plus b whole square plus a minus b whole square would be written as twice of a square plus b square. If you have a plus b whole square minus a minus b whole square, it will be written as 4ab. Now if you want to look at this, this is actually a plus b whole square is a square plus b square plus 2ab, and a square minus b square is a square plus b square minus 2ab. So plus 2ab and minus 2ab gets cancelled out to give you an answer 2a square plus b square. Similarly here a square and b square will get cancelled out and 2ab things will get added up to give you an answer of 4ab. The next one being a plus b plus c whole square would be equal to a square plus b square plus c square plus twice of the different combinations of a, b, b, c and c. So these are the basic identities that I need to remember when I am solving the questions on algebraic expressions. Let's look at a question. The question is, if x square plus y square plus z square is equal to 121, x, y, z is equal to 108, 1 over x, 1 over y, 1 over z is equal to 7 by 9. And it is given to you that x, y, and z, all of them are greater than 0, that means they are positive. Then you have to find out the value of x plus y plus z, mod of it. Mod means your answer will always come out to be positive. So if I just look at the things, if I just go back and look at the formula that I have for a plus b plus c whole square, it was a square b square c square to ab bc c. And if I try to apply it here, because I have certain thing like that only. So if I just look at it, x plus y plus z whole square would be equal to x square plus y square plus z square plus 2 times xy, yz and zx. Now this value is anyways given to me as 121 plus 2 times. Now when you have a question like this, x, y, y, z and zx. Now if you look at it, you have this thing. If I just try to take an LCM, I'll have an LCM x, y, z, and the numerator I'll have x, y plus y, z plus zx. So this is actually the same thing, and this is equal to 7 by 9. So 7 by 9, I can get this value if I just put 108. So this value is actually 108, which is again a multiple of 9. I can cancel the things. So if you just look at it, it is the 12th multiple that I have from for 9. 12 9s is 108. So the value of this is coming out to be 12 into 7 into 2 plus 121. Now if you want the value for x plus y plus z, I'll have to take a square root of this. So once I take the square root, I'll get 17 as my answer for x plus y plus z modulus value. The other basic algebraic identities that I need to remember is a plus b whole cube, which is equal to a cube plus b cube plus 3a square b plus 3ab square. And if I have a minus b whole cube, it will be equal to a cube minus b cube minus 3a square b plus 3b square. A cube plus b cube would be equal to a plus b into a square minus ab plus b square. The The fourth one being a cube minus b cube. It will be a minus b, a square plus b square plus ab. So the minus thing will only be in the first one and not in the second multiplication thing. If you have, the next that you have is a cube plus b cube plus c cube minus 3abc would be equal to a plus b into a square plus b square plus c square minus ab minus bc minus c. And if a plus b plus c is equal to 0, if a plus b plus c is equal to 0, then a cube plus b cube plus c cube, if you put right hand side a plus b, if you put this thing a plus b plus c equals to 0, then the left hand side would be equal to, the left hand side would be equal to the right hand side, which is actually 0. So a cube plus b cube plus c cube would be equal to a 3abc. Let's look at the question that we have based upon this algebraic identity. 24 cube plus 26 cube plus minus 50 cube is equal to. Now if you look at it, 24 plus 26 minus 50 is equal to 0. That is the thing that we have. So what I need is, if a plus b plus c is equal to 0, the value of a cube plus b cube plus c cube is equal to 3abc. Now the answer will be 3, 24, 26 and 50 with a negative sign. I need not solve this thing out because if you look here, 0 cannot be the answer. There are two answers which are similar, one with a negative sign and one with a positive sign. So my answer has to be negative. That means A option will be my answer. Anyways, when I'm multiplying certain big numbers, 1248 cannot be my answer. Very simple thing. So my answer is option number A. Let's look at another question. You need to find the value of a cube plus b cube plus c cube. Again, when I look at it, 526, 474 and 1000 adds up to 0. So I'll have a cube plus b cube plus c cube is equal to 3abc. Now a is also negative and b is also negative and c is positive. So the product of all of them would be positive, giving C option as my correct answer. Let's understand the next concept, which is zero of a polynomial. Zero of a polynomial. Now, let's look at a polynomial which is given to us, 5x cubed minus 2x square minus 2x minus 5. So, it's a cubic polynomial. Why? Because it's a 3-degree polynomial in one variable only. I have only one variable which is given to me, which is x, and it's a cubic polynomial. Now, if I put x is equal to 1 in this, so if I just put x is equal to 1, it will be 5 minus 2 plus 2 minus 5. You will see that px comes out to be 0. That means if I put my input, this will be known as an input. If I put my input as 1, the output that turns out, which is the value of px, turns out to be 0. So such an input, such a value of input x which satisfies px is equal to 0 or which gives the output as 0 is known as 0 of a polynomial. So such values of input which gives output as 0 is known as 0 of a polynomial. The next thing that we'll discuss would be remainder and factor theorem. Looking at the remainder theorem, I have a certain algebraic expression given to me. Again, it's a cubic equation in one variable which is given to me. So you have x cubed plus xx square minus 19x minus 24. And the question is, divide this with x minus 2. Now instead of actually dividing, what I'll do is, I will put x is equal to 2. If you have this, I will put x is equal to 2 and try to find out my answer. If you put x is equal to 2, the value of px is coming out to be minus 30. And this value will be known as the remainder of this expression when I divide it with x minus 2. So instead of actually dividing and finding out the remainder, what I'll do is, if I'm dividing it with x minus a, I'll put x is equal to a. Or if I'm dividing it with x plus a, I'll put x is equal to minus a and find out the value of output. The The output basically tells me the remainder. Factor theorem. Now, if the same expression is divided by x plus 1. So x plus 1 means I'll put x is equal to minus 1. When I put x is equal to minus 1, the value of output comes out to be 0. That means the remainder comes out to be 0. If the remainder comes out to be 0, that means x plus 1 is a factor of px. So what I do is I basically put the value in the algebraic expression and try to find out the remainder. If I have a certain remainder, that is your answer. If your remainder turns out to be 0, that means the given number or the given expression is a factor of the algebraic expression that is also given to you. Let's look at an example. Find the value of k for which the expression is divisible by. Divisible means if I have this as an expression, x cube plus kx square plus 3x plus 4. If I put x is equal to minus 3, the value of output should be 0. That means if the input is minus 3, the output should come out to be 0. So I'll just put that minus 3 cube plus k minus 3 square plus 3 into minus 3 plus 4 is equal to 0. So what you have is minus 27 plus 9k plus 9 plus 4 equals to 0 that we have. So sorry, this will be minus 9. Minus 9. So if you just try solving this thing, this will be minus 5. Okay. The value of k comes out to be, it will be in plus 32 by 9, which is the correct answer that we have. So if I have this value of k and if I put x is equal to minus 3, it will turn out to be a factor. Now the next thing that we'll discuss is the concept of linear equations. Linear equation. Linear equation, as the name suggests, is an equation of degree 1. The degree of this equation is 1. And if you plot the graph of this, it will be a straight line extending till infinity. It's a straight line graph that you get for a 1 degree equation, therefore termed as linear equation. So, linear equation is an equation of degree 1. You can have linear equation in one variable, you can have it in two variables, you can have it in three variables, or you can have it in any number of variables. But an important thing to notice, the degree should always remain 1. The degree of the equation should not change. There are certain important rules that you need to keep in mind whenever you are solving a question on linear equation. Now, in a linear equation, when a same constant is added or subtracted from both sides of an equation, so you have an equation. So if you add a constant on both sides of an equation, or if you subtract a constant from both sides of the equation, the equality is preserved. So, and the new equation that you get is equivalent of the original equation that you have. Similarly, if both sides of an equation are multiplied or divided by the same non-zero constant, the equality is preserved and the new equation is equivalent to the original equation that you have. So you have an equation. If both sides you're multiplying it with the same constant, non-zero constant, it will still maintain the equality sign and the new equation will be equal to the original equation that you have. Okay, so let's discuss about linear equation in one variable first. So linear equation in one variable means variable has to be 1 and it has to be a linear thing. That means the maximum power of that one variable which is given to you has to be 1. To solve the linear equation in one variable, we'll simplify each side of the equation by combining the like terms. So I'll look at the like terms and I'll try to combine them, and therefore I'll solve a linear equation in one variable. So this equation is given to you. What I do is I first try to open up the things and I try to combine the like terms. Again, bring 2x to this side. So this will be, this 2x will be cancelled. So 3x will be equal to I'll get the value of 12 and x comes out to be 4. So it's a single point that you have that I can mark on the graph, or I should say a number line. This is the solution for this equation, which is an equation in one variable. So it is also possible for a linear equation to have no solution. It is not mandatory that a solution should be possible all the time. For example, if I take this equation, because if I just look at it, it will be 2x plus 3 equal to 2x plus 14. 2x get cancelled out from both the side. I'll have 3 is equal to 14, which is a false statement. So if you have a linear equation like this, it has no solution to it. Also, it is possible that a linear equation in one variable turns out to be an identity. Identity means it tries to have a fixed value. So for example, 3x minus 6 is equal to 3x minus 6 on this side as well. So if you just open it, it will be minus 6 plus 3x. Now, their left hand side and right hand side are true for all values of x. So it's an identity that we have. Let's talk about linear equations in two variables. A linear equation in two variables, x and y, can be written in the form ax plus by equals to c, where a and b are the coefficients of the variables x and y. So x and y that you have is a variable, a and b are the coefficients of these variables, and c is a constant that you have on the right hand side. Now, the solution for such an equation will be in terms of x and y. And such an equation, the solution is termed as an ordered pair. Ordered pair xy. That makes the equation hold true when the values of x and y are substituted into the equation. So when I substitute the value of x and y, I'll have the equation hold true. So for example, you have 3x plus 2y equals to 8. And if I try to fit in the values of x and y such that my left hand side is equal to right hand side, all those values will be known as solution to this equation. So if I just look at this, if I try to fit in the values, if I put x is equal to 2 and y is equal to 1, it will be 6 plus 2, which will be 8. So 2, 1 is a solution that I have for this equation. Another solution that I will have will be minus 2 by 3 and 5 will be a solution to this equation. So this linear equation in two variable, if I try to plot, it will be a line which looks something like this. It will have infinite many solutions because all the points on this line will be satisfying the equation of this line and therefore will be a solution to this line. So therefore it is possible to find the integer solution or positive solution, but if you want to count the number of solutions, there will be infinite many solutions that will be possible for this equation. If two equations are given to you simultaneously, then it is known as system of equations, and it is possible for you to find a solution for system of equations, and that solution should simultaneously satisfy both the linear equations which are given to you. To solve this system of two equations means to find an ordered pair that satisfies both the equations. So let's look at the various cases that I will have. These are the set of equations which are given to me. So I have two equations in two variables, and these two equations that I have are linear equations. That means the powers of both variables x and y is 1. The degree of this equation is 1. To solve this two system, I have to find out a common ordered pair of numbers that satisfy both the equations at the same time. Now how I'll do that? there are basically two methods for solving system of linear equation. One is substitution. So what I do in a substitution method is one equation is manipulated to express one variable in terms of another. Then this expression is substituted in the other equation. Now for example, if I have this, if I multiply this equation with 4 and subtract it, x will be eliminated. So I try to manipulate the equation so that I eliminate one of the variable and I get an expression only in terms of another. So if I just do that, x will be eliminated and I will have the value of y. So when I try to find out the value of y, I am actually getting left hand side and right hand side as 0. What does it mean? We'll just interpret it later. Let's try to just solve the equation. So if you have this, if you just again multiply the first equation with 4 and subtract it from the second, x thing is eliminated and what you get on your left hand side and right hand side is 8 is equal to 8 is equal to 13. Now in case you look at the third equation set that is given to you, you multiply the first equation with 4 and subtract it from 2, the y thing is not actually getting cancelled out. You are getting the value of y is equal to minus 1. Now substituting in any of the equation, you are getting the value of x is equal to 4. So the ordered pair that I will write will be 4 and minus 1. Now here I am getting a unique solution. There is an ordered pair 4 and minus 1 which is satisfying equation number 1 and 2 at the same time. This is known as a simultaneous solution, unique solution to both the equations. Now if your left hand side and right hand side are both coming out to be 0, that means the two lines that are anyways given to you are overlapping lines. Now whenever the lines which are given to you are overlapping lines, every point on line 1 will be able to actually satisfy the equation of line 2 and therefore you will have infinite many common solutions to both the equations. Now if your left hand side and right hand side are not equal, like 8 is equal to 13, 8 cannot be equal to 13. That means this is a situation when the two lines which are given to you in the equation are parallel lines. Now I know a set of parallel lines would never ever intersect. If they never ever intersect, there is no common solution which can satisfy both the lines simultaneously. So in case of a parallel line, I have no solution. In case of overlapping lines, I have infinite many solutions. And in case of unique solution, I have a set of single value of ordered pair x and y that satisfies both the equations. Now, I actually don't do all of this when I get a question. I just look at the rule and try to answer this question. So what is the rule? The rule is, let's take these set of two linear equations which are given to us. Ax plus by equal to c, px plus qy equal to r, where a, b, p and q are the coefficients, x and y are the variables, c and r are constants that you have. Now what I'll try to do is, I'll find out the ratio of a over p, b over q and c over r. So I'll try to find out a over p, b over q, c over r. If a over p is equal to b by q is equal to c by r, that means they are basically the equations of overlapping or coincident lines. And whenever you have overlapping or coincident line, there will be infinite many solutions possible. If a over p is equal to b by q but not equal to c by r, that means it's an equation of two lines which are parallel to each other. Parallel lines do not intersect. So there is no common solution that you have for these two equations. If a over p is not equal to b by q, that means you will have a unique solution and the two lines will intersect at some point or the other. So I'll have a unique solution if a over p is not equal to b by q. And I'm not looking at c over r in that case. However, if a over b is equal to p by q, I'll look if it is equal to c by r or not equal to c by r. If not equal, it will be parallel lines. If equal, it will be coincident line, giving me no solution and infinite many solutions respectively. Let's look at some questions on linear equation. At a fruit stand, Apples can be purchased for 0.15 each and pears for this. So the price of one apple is $0.15 or one pear is $0.2. At this rate, a bag of apples and pears was purchased for $3.8. If the bag contains 21 pieces of fruit, how many pieces were pears? Now, if I suppose the number of pears were x, so how many apples were there? 21 minus x. I will try to form the equation as follows. The price of one apple is 0.15 multiplied by the quantity of apples. So this will be the total price that I end up spending on apples. Plus the price of one apple is 0.2 and the number of apples is x. So the total price that I end up paying is 3.80. So this is the equation that we get. 0.515 into 21 minus x plus 0.2 into x equal to 3.8. So if you just solve this thing out, this will be 3.15 minus 0.15x plus 0.2x equal to 3.80. So if you just try solving this equation, the value of x comes out to be equal to 13. And that is what you needed to find. The number of pears comes out to be equal to 13. The next example that we have is the linear equation this and this. So if I look at the value of a is 3, b is 4, c is 18, p is 6, q is 8 and r is 20. If I look over a over p, b over q and c over r. A over p is 3 by 6, 4 by 8 and 18 by 20. If I look at it, 1 by 2, 1 by 2. So this thing is equal but not equal to this. So that means the two lines that you have are parallel lines with no solution. Giving option number A as my correct answer. Thank you so much for watching the video. Please move on to the second part of algebra to start with quadratic expressions.